All right, and welcome to homework lecture number 4. This one is covering conversions. Now, need conversions for cooking world, obviously, if we want to convert from small measurements to big measurements. We also need it for scaling recipes and everything later on. So it's important to have this section really down before we get into other things. Conversions are important for everything involving cooking and business because you're going to be wanting to sell things, your menu items by a certain price. Maybe if you're doing catering, how much you make per dollar on a certain item, menu pricing, recipe cost forms, all that stuff is going to come into play whenever you're doing conversions. So we're going to be talking about conversions and rates with all of this. So let's start off with something a little bit more simple. Let's look at question number 1 from the homework. Now, this might come to you intuitively in the cooking world, but we want to convert quarts to gallons. So this question on My Math Lab wants us to take 64 quarts, and it wants us to convert it to gallons. Now, some might think right away, like, oh, you divide it by 4, if you've been taught that way to memorize these easier conversions, and that's totally fine. You would, in fact, divide that by 4 because you're going from a small measurement to a larger measurement. So when you go from small to large, you divide because the number should be smaller. When you divide a number, it becomes smaller in the sense of dividing a whole number with another whole number. So yes, you can divide it by 4 to figure out the answer, but this is what we're going to be doing for most of the classes, this string of rates and ratios and conversions. So what we do is we take our initial amount, 64 quarts, and abbreviate that with QTS, quarts. We want to convert it to gallons. So this is our end goal, and we want to get there. So what we need to do is set up a ratio that gets us to a path to convert quarts to gallons. Here's where your conversion chart comes in handy. You'll see the conversion chart up on the Moodle page. You can use that conversion chart to find a number of conversions to get the answer. One of the conversions will say, for every gallon you have 4 quarts. So for every 1 gallon, you have 4 quarts. So when we convert this 1 gallon and 4 quarts, this is how conversions will work. I'm going to multiply by this ratio right here. So this is called an equal ratio, meaning it's equal and proportional. 1 gallon is the same thing as 4 quarts. 4 quarts is the same thing as 1 gallon. It's like when you're talking about exchange currency. Currently, like the Mexican peso is a little above 20 pesos for every US dollar. So for 1 US dollar, you get 20 pesos. So that's what it is. It's the same monetary amount. It's just in different measurements. Now, we want to get to gallons. So to get to gallons, what we're going to do is this. We're going to write gallons up on top and quarts on the bottom. And we're also going to carry the number associated with them. For gallons, it was the number 1. So we're going to put 1. And then for quarts, it's the number 4. So this right here makes a multiplication ratio. It's a conversion ratio is what we're using. And what happens here is our goal is to have our top unit be our end unit that we want, which is gallons. And what happens here is when we divide the 2 quarts together, they end up canceling out because they're the same thing. So when you cancel out the quarts, we're left with gallons as our unit of measurement. That's what will be left over. Now what you do is you just go ahead and divide and multiply everything within the string. If you want it the easiest way is to multiply everything on the top first. So 64 times 1 makes 64. And then multiply everything that's on the bottom right here. Remember with fractions, we have like an imaginary number 1 there if there is no number there to hold its place. So 1 times 4 makes 4. And you can see in the end it makes 64 divided by 4. So 64 divided by 4 then gives you the answer of 16. And so it would be 16. What are we talking about? Gallons was our only thing that we had left over. And that would be your answer for that. So these conversions, at least these simpler quote-unquote conversions, aren't as difficult as what we're going to come up with towards the end of this lecture. We'll have to make a chain of these ratios, but we'll get there in due time. Let's try another conversion for number 2. It says to convert 14 cups, and it wants it into fluid ounces. Now, notice the fluid, that means it's a liquid measurement, not a weight measurement. It's easy to confuse ounces with ounces if one isn't fluid ounces and the other one is ounces. Remember, ounces is weight, fluid ounces is volume. So remember that difference. So it's a volume to volume, volume conversion. So we can come up with another ratio. Let me put a little divided there. And cups to ounces, there's also a conversion for that. For every 1 cup, there's 8 fluid ounces. So for 1 cup, there's 8 fluid ounces. We go ahead and start out with our beginning measurement, which is 14. That's 14 cups, which I'll abbreviate with a capital C. That's how you'll see it on your recipe forms. 14 cups times. Now we want our end result to be fluid ounces. So we want fluid ounces to be up on the top. And then on the bottom would be the other one. Since we put fluid ounces on top, we want cups to be on the bottom. And this would make 8/1. As you can see, our goal was to have fluid ounces left because the cups cancel out. And you go ahead and multiply across. So 14 times 8 then gives you 112. 112 fluid ounces. And that's your answer for that problem. So 112 fluid ounces. These are all one-step conversions. Let's try another problem. Let's go ahead and do that's not number 3, number 4. This one says 28 ounces, and it wants us to convert it to pounds. So it's a weight-to-weight measurement. This is weight in ounces and weight in pounds. So we can come up with another conversion. For every 1 pound, I'll go ahead and abbreviate with the pound sign or the hashtag sign, whatever y'all see it as. The 1 pound is equal to 16 ounces. So for every 1 pound, we have 16 ounces. Set up your conversion line. Start with what you're known, 28 ounces. Since we want pounds up on top, we have to write down pounds, and then the ounces would go on the bottom. The one we want is written on top, the other one is written on the bottom. So for every 1 pound, there's 16 ounces. And as you can see, ounces cancels out. We're left with pounds. 28 times 1 makes 28, and then 1 times 16 makes 16. You can go ahead and divide those out, and that gives you 1.75 pounds as your answer for that problem. So again, a lot of these are one-step problems. We'll get into some more complicated ones, but I just want to be very thorough with these examples. Number 5 has 19 pints is equal to what amount of cups? Again, we know for every pint there's 2 cups within it. So if you're going from a large measurement to a smaller measurement, meaning pints are larger than cups, you would multiply the number. Unlike that gallons and quarts, if you go from quarts to gallons, that's a smaller unit of measurement to a larger unit of measurement. So you divide. Here, pints to cups, we should see a higher number for cups since they're smaller. You could say, since there's 2 cups for every pint, just multiply by 2, and that would give you 38. But again, if you do it this way, you can use that ratio, the same ratio we just mentioned, for every 1 cup, for every 1 pint, for every 1 pint, there's 2 cups. And then we would write 1 pint on the bottom because we want to have cups as our end result. So pints cancel out, and then you're left with 38 cups as the answer. All right. So some of these things, I want you all to be able to try some of them by yourselves, but I like to kind of mix it up and have some examples here and there that help you with every other problem. So I'm not going to go through all of them, but let's try number 8. This one wants us to change 24 fluid ounces into how many tablespoons? All right. So this one, we start out with ounces and tablespoons. Now, on the conversion chart, you can find what a tablespoon and an ounce conversion is. You find it for the metric one, you find it for the regular ones. But in this case, since we may not know how many tablespoons are in a fluid ounce, what you can do is back it up a little bit. Over here, I have gallons, quarts, pints, and cups to an equivalent amount of ounces and tablespoons. So for instance, if you didn't know how many ounces are in a tablespoon, like if you didn't have that ratio, we can figure that out. So here, 24 fluid ounces, I'm going to write that down. That's our starting measurement. On my conversion chart, I do have a cup to tablespoons conversion, but I do not have a fluid ounce to a tablespoons conversion on there. So what we can do is convert backwards and then to the tablespoons, and that could give us a new conversion. So 24 fluid ounces, maybe I want to convert that to cups really quick. For every 1 cup, we have 8 fluid ounces. And then I want to make another conversion from that. So I'm going to first change this to cups. For every 1 cup, we have 8 fluid ounces. Then what we can do is we can convert it to tablespoons. We can take that 1 cup measurement and convert it to tablespoons. According to the conversions, 1 cup is equal to 16 tablespoons. Capital T represents tablespoons. Lowercase t would be teaspoons. So I can set up that conversion. I can get rid of cups, put it on the bottom, and then have tablespoons on top. Now I can go ahead and multiply everything on the top, 24 times 16. That gives us 384 divided by 8 times 1. 384 divided by 8 then gives us 48. So that gives us 48 tablespoons. And that would be our answer for that problem. So we did a roundabout way of getting to the answer. Now we could figure out a conversion for this. So let's remember this. 24 fluid ounces is equal to 48 tablespoons. 24 fluid ounces is equal to 48 tablespoons. That's a ratio. So we can make our own. We can say for every 48 tablespoons, we have 24 fluid ounces. Or we could say the other way, 24 fluid ounces, we have 48 tablespoons. And you can reduce that. So I showed you how to reduce fractions. The largest number that goes into both 48 and 24 is 24. We can divide 24 on each one of these separately, which would then reduce it to 2 tablespoons over 1 fluid ounce. Or for every 1 fluid ounce, you have 2 tablespoons. So there's a new conversion that you could have written on the chart. 1 fluid ounce is equal to 2 tablespoons. And that could be used as a new ratio. And we could have used that in the very beginning on the other problem. So if I copy this problem, the 24 fluid ounces, 24 fluid ounces equals blank tablespoons, we can use our newfound conversion to figure it out. 24 fluid ounces times, I want to get rid of fluid ounces, so I put it on the bottom and I put tablespoons up on top. Fluid ounces cancels out and we end up getting 48 tablespoons. We end up getting the same exact answer as we did over here, because here fluid ounces cancel out, cups cancel out, we're left with tablespoons. Here we get the answer right away. It's because we found this new conversion. And maybe you knew that conversion already. Now, I didn't have that one up on the conversion chart. I tried to put more of the more common ones. Can't say I've seen that one come up very often. But you can make up any of your own conversions. Like I might not have one that says gallons to tablespoons. Well, maybe I don't need to count how many tablespoons are in a gallon, but you never know. Maybe it comes up. You can make that conversion and make up your own equal conversions. All right. So let's look at another problem. This one's interesting. Number 10 wants us to take 1 1/3 tablespoons. I'm going to abbreviate now, capital T, into blank teaspoons. So if you look over on the conversion chart, we do have one conversion that says for every 1 tablespoon, that's equal to 3 teaspoons. And we can use that conversion to go from tablespoons to teaspoons. However, we don't really like working with fractions when we're doing this, especially 1 1/3. So let's change that 1 1/3 to an improper fraction. Remember from the other lesson, 3 times 1 plus 1 would give us 4/3 tablespoons. So we're going to use that one. 4/3 tablespoons is going to be our beginning problem. We're going to multiply it by this ratio. Put 1 tablespoon on the bottom, 3 teaspoons up on the top, and you can see tablespoons cancel out. And that gives us a new number. You can say 4 times 3 is 12, then 3 times 1 is 3. 12/3 like that. And that gives you 4. That gives you 4 teaspoons. But remember, you could have also done the cancellation method. These are the same numbers. There's a tablespoon, tablespoon, teaspoon. Those cancel out. You can see that the 3's also cancel out, and then that would just leave you with the number 4. You can get the answer both ways, but it's a matter of how comfortable you are with the method that you're choosing. So that's conversions. Those are like 1 or 2 step conversions when they're in the same type of unit of measurement, meaning volume to volume, weight to weight. And then you might have other ones like distance to distance. Those are our main 3 ones that we convert with. You have other units of measurement like time as well, or density, all this other stuff. But we won't be going into any of that. Your main ones are volume, weight in the cooking world. So let's look at number 11. This one wants us to convert 21 liters to milliliters. Now, the metric system is actually really easy to work with if it's within the metric system, meaning if we're doing centimeters, meters, kilometers, we're doing milliliters, liters, kilograms, grams. All these little conversions from small to big are easier because they're done with a decimal movement. So anytime you're going from some unit of measurement to another one, you just move the decimal unit. So for instance, I show on your conversion chart in the very bottom left corner some examples of how the numbers are converted. But let's take like a number like, we'll say 10 kilograms. Well, kilograms can go to grams, and then that can go to milligrams. And then we could also do the converse. We could say milligrams could go to grams, grams could go to kilograms. Depending on the movement that you're doing, you move the decimal place over 3 units in terms of kilo, meaning the K, the unit of measurement, and the milli. We won't be working with things like centa or micro or nano, all those other ones. We're working with the common ones, which are milli, the base unit, and kilo. So anytime you go from a larger unit of measurement to a smaller unit of measurement, you're going to take the decimal point and move it over 3 times. So I'm going to take the number 10, and the decimal place is right here. If we move it over 3 times, like this, I put little spaces in between each one. And in each one of those spaces, we're going to put a number, 0, 0, 0, 0. So that means this would be 10,000 grams. Now we do the same thing for the next one. If I have 10,000 and I want to move it to milligrams, I have to move it over to the right 3 times. I'll do purple. And we put a 0 in the place of every one of those. So this would be 10,000,000,000, 10 million milligrams. And that would be that number right there. So anytime you're going from large unit of measurement to a smaller unit of measurement, you're going to move the decimal place to the right because it makes sense. Kilograms is much heavier than milligrams. I mean, they measure human weight by kilograms. They measure dosages of medicine by milligrams. So think of it that way. Like a milligram is what you measure like your ibuprofen and your Tylenol in. Kilogram is what you use to weigh people in. You're not going to tell the person, oh, they weigh, or something weighs 10 million milligrams. That's unsensible. It doesn't really make sense. Somebody can't really put that in perspective because, how much different is 10 million from 15 million milligrams? In the weight world, it's not too much, but in the medicine world, it's a ton more. So, no pun intended, a ton more. But anyway, anytime you're going from large unit measurement to a smaller unit measurement, move the decimal place over to the right. So let's try that again. Let's say we have 0.5, and I will say kilometers. We're going to talk about distance, kilometer. If we want to go to meters, that would be the next one. We have to move this decimal place over to the right 3 times. So take the decimal, move it to the right 3 times. 1, 2, 3. And put a 0 in each one of those spots. That would give us 500 meters. Next, take the 500. If we want to make that into millimeters, we have to move the decimal place over 3 more times. 1, 2, 3. And that gives us 500,000 millimeters. So again, think about a ruler, a standard 1-foot ruler. You'll notice on the other side of most rulers it has centimeters and meters. And millimeters are the tiny little tick marks, right? There's 500,000 of those little marks on the ruler in half of a kilometer. So that makes sense. In half of a kilometer, that's a decent walk. There's 500,000 of those tiny little dashes in it. And that makes sense. So always make sense of the way you're moving the decimal. Larger units going to smaller units should appear to be bigger numbers. But let's look at the other way around. Let's look at, I'll come back to number 11. I'll write it down. Let's say we have 1,200, and I'll say milliliters. Let's go to liters, and then we'll go to kiloliters. So 1,200. This time we're going from a smaller unit of measurement to a larger unit of measurement. So in this case, we don't want to make the number look bigger. We want to make the number look smaller. So we're going to take that 1,200, take this decimal right here, and instead of moving it to the right, we're going to move it to the left. And that would make the new number 1.2. So there's 1.2 liters and 1,200 milliliters. Again, that makes sense. There's a lot of little small liters inside a bigger liter. And that's the idea. So when we have 1.2, let's take that 1.2. And we need to move that decimal over 3 more times to the left. And in each one of those blanks, we'll put a 0 in its spot. So that'd be 0.0012. You won't see kiloliters very often in the real world. A lot of people just use liters because they're easier to read. But a kiloliter still exists. So 0.0012 kiloliters. That's a very small number. But given you were only talking about 1,200 milliliters, which isn't too much. So you might see these kind of Well, 1,200 milliliters is a lot in terms of uh, water, milk, very common things. That's actually a lot. In gallons of milk sounds about accurate. And then that's how they sell alcohol is by the milliliter, 750 milliliters, 1.75 liters. There's just different ways. It just depends on what we're talking about. So a smaller unit measurement going to a larger unit measurement always make the number look smaller. So going back to our other question on number 11. Number 11 is saying 21 liters equals blank milliliters. So that's a one-step move. It's from liters to milliliters. It's a larger unit of measurement going to a smaller unit of measurement. So there's a lot more of these guys inside one of these. So we need to make the number 21 make it look larger. So move it over to the right 3 times. And that gives you 21,000 milliliters. That'd be your answer for that one. That's all there is to it. It's just a matter of learning on how to do it. Number 12 says take 12, not 12, for mine it says 17.9 milliliters, and we're converting it into liters. So a smaller unit measurement going to a larger unit measurement. So the number should look smaller because we're going to a larger unit of measurement. We have to move the decimal place over 3 times to the left and put a 0 there. So your answer for that one would be 0.0179 liters. And that's all there is to it. Now remember, these are all metric conversions. These aren't imperial, which is like the US metric, or to US metric, is the US measurement system to the metric. That's different, which is what we're going to go over now. But anytime it's metric to metric, all you have to do is do this decimal movement. Move it 3 times to the left, 3 times to the right. And again, that's only for milli, and then the base unit, and then kilo. If you take any other science course, you might work with centa, and then nano, micro, depends on what you're talking about. But you might work with all those other unit measurements. But in the grand scheme of things, they all just move over by 1 decimal movement. And that's how conversions work with metric system. Now here's where it gets a little bit more complicated. 15, anytime we're converting between 2 different measurements, 48 gallons equals what liters? Here we have a gallon, which is a US measurement, to a metric unit of measurement. That's different. So when we have something like that, we actually have to figure out a conversion, and that's where your conversion chart comes into play. You have to pull up this conversion chart. All these were pulled off of like Google when you would type in like, what's 1 inch to centimeters, and it'll give you a conversion. All these I rounded to the most exact reasonable possible value. So here I'm looking at my conversion chart, and it has gallons to liters. So you want to look at your center one, the US imperial to metric, because we're going from imperial to a metric unit of measurement. And we want to look for the gallons to liter one. Here we have, according to the chart, 1 gallon is equal to 3.78541 liters. Now, the reason why I have all those decimals is because the more decimals you have, the more exact your answer is going to be in the end. If I didn't include like 2 or 3 extra decimals on the end, my answer won't be as exact as it would be if I included more decimals. In this sense, some of these measurements, these conversions have infinite decimal places, like they keep going, some don't. But the more you have, the more accurate your final answer would be. So we're going to use that conversion for this. This is 48 gallons, and we want to change it to liters. So we're going to put 1 gallon on the bottom and 3.78541 liters up on top. Reason being is because our gallons cancel out. And all you got to do is multiply the 48 times the 3.78541. So 48 times 3.78541, type in on the calculator, is 100. Oops, I'm going to keep it in the black ink. 181.69968. That's the number I get, and that's liters. On our problem, it says to round to the nearest hundredth place. So round, I'm going to put this little about equal sign. 181 point nearest hundredth place would be 69. So we need to round it for this is the hundredth place. So this number has to round up. That would make the 9 a 0, which in turn would round the 6 up. So it'd be 70. So we get 1.81.70 liters. All right, so let's try another problem like that. I'm going to show you all another little trick when it comes to conversions. For number 16, it wants us to convert 29 quarts to liters. If we go on the conversion chart, since again I'm going from imperial to metric, we look for the imperial to metric conversion. It says for every 1 quart there is, I'm going to write this down a little lower because it's a big number. So for every 1 quart, there is 0.09463353 liters. And we can use that conversion. 29 quarts times 1 quart on the bottom and oops, there shouldn't be a 0 on there. I apologize. It's supposed to be 0.9. That would have been a very small number. So 0.9. So 0.946353. 46353 liters. Quarts cancel out. So 29 times 0.946353. That gives us 27.444237. That's a 4. Liters. Our question wants us to round it to the nearest hundredth again. So this would be our dividing line. We don't round up in this case. It would be 27.44 liters. So that's how you could find the answer that way. Now, if you notice on the left-hand side of the conversion chart, I also have metric to U.S. imperial. Let's take the same exact problem, number 16. And we're going to convert it. But this time, what if I looked at the blue column on the conversion chart? If you look on the left side, all we need is one that says liters and quarts. That's our goal. It just has to say liters and quarts. There is one, and it says for every 1 liter, there is 1.05669 quarts. Well, that's a different conversion ratio, but these are the same thing. They're equal. It's just the way we look at it. So we can use this conversion for this one. 29 quarts times. Remember, quarts goes on the bottom. It would be the 1.05669 quarts and 1 liter up on top. Again, the quarts cancel out, but this time you're going to have to divide them out. 29 times 1 makes 29, and then that's just going to be 1.05669 anyway. We have to divide them out. 29 divided by 1.05669. Since we're dividing, the number I get is much larger looking. It's not, in essence, a larger number in terms of value, but it gives us a lot more numbers because when we divide, we usually get more numbers in the end. See how this number right here wasn't as long as this number? That's because this number is limited by however many decimal places I have here, whereas this one can go infinitely whenever we divide. But again, look at the answer. We want to round it to the nearest hundredth. Divide it right there. It'd be 27.44 liters. We still get the same answer. So it doesn't matter which one you use. You can use the US imperial to metric or the metric to US imperial measurement. The ratio doesn't matter. It's a matter of doing the math correctly and setting them up correctly. We still do liters on top, quarts on bottom. Liter on top, quarts on bottom. But you have a choice. It doesn't matter which way you do it. Either way is going to be correct. Technically, I guess the more accurate way would be the top way, but in the grand scheme of things, it really doesn't matter, especially when you're rounding to the nearest hundredth. As you can see, the numbers only differ right around here, this 2 and this 1 right here. That's where they differ. It's 27.444 for all of them. One of them says 2, one of them says 1. That's where it starts to differ, but that's on the 10,000ths place. So it really doesn't matter in this case. So you have a choice whenever you're doing those two numbers. You can choose whichever one. So let's look at another example I have here. We're not going to do another metric conversion. We've done so far we've done U.S. imperial to U.S. imperial. We've done metric to metric, and then we've done U.S. imperial to metric and vice versa. But let's talk about temperature. We have some basic temperature ones, and I'm only going to do one problem of each. Number 23 on the homework. Number 23 says to convert 98 degrees Celsius to degrees Fahrenheit. Now, if you look on your conversion chart, the bottom right corner, you'll see the two formulas. If we're looking here, it wants us to find degrees Fahrenheit on our particular problem. So on our conversion chart, we want the one that says F equals because we have what C is already. So we say F equals 1.8 times C plus 32. Since we have our degrees Celsius, we can just plug that in. F is equal to 1.8 times 98 plus 32. Remember, your PEMDAS says to multiply first. So we have to do 1.8 times 98. That gives us 176.4. And then we can add the 32 afterwards. Once we add 32, that gives us 208.4 degrees Fahrenheit. And that would be your answer for that. So here it's just following the formula. There isn't like a ratio problem that we need to do. Whereas if we do, let's look at another problem, one with Fahrenheit, number 25. Wants us to convert 41 degrees Fahrenheit to degrees Celsius. We need to use the one that says C equals because we're trying to find what C is equal to. So C equals, this one says F minus 32 on top divided by 1.8. So as you can see, we have the parentheses. The parentheses means we have to evaluate what's on top first. So our F is going to be 41 minus 32. So we have to evaluate the 41 minus 32 before we divide by 1.8. That gives us 9 on top, 1.8 on the bottom. Divide those out, that gives you 5 degrees Celsius. And that would be your answer. So I got 5 degrees on there, and 208.4 degrees Fahrenheit for the other one. So whichever one is the blank one, that's what you want to set it equal to. So we said F equals because we were trying to find F. We said C equals because we were trying to find C. Wanted to find the amount for degrees Celsius. All right, so let's look at another problem. It's about like something that's like a rate. What you'll see up on this one's a cereal box, but you'll see like ounces per serving, liters per serving, milliliters per serving, on bottles, boxes, whatever it is that you shop for. This one in particular for number 29, I'm going to paraphrase. It says there are 660 grams of cereal. Oops, that's cereal in a family-sized box of Raisin Bran. Cereal. Family size Raisin Bran. That'll start the morning pretty good. The box contains, it says it contains 12 servings. It wants us to find out how many ounces is one serving. So it wants ounces per serving as our question. It wants us to find out what it is. So we need to put that in perspective. We need to figure out how many ounces are in a serving. We're given grams. We want a weight of ounces instead of grams. So we have to set up a conversion line. So what we're going to do is we're going to start out with what's given to us. The only number that's really given to us that equates to ounces, our weight measurement, is the 660. So we're going to say 660 grams. And I'm going to move this a little lower so we can, oops, that's not what I wanted to do. We will just go ahead and erase that. I just wanted to move it. 660 grams, going to write it way down there because we have some conversions. So we want to convert grams to ounces. We can write down that conversion, and we have one on here for our metric, US to metric or metric to US. So under the weight and mass one, I'm looking at for every 1 ounce, we have 28.3495 grams. Now, there is another one on there. You could have used 1 gram is equal to 0.035274 ounces. But because this is like a smaller number, it's a little bit, worse to work with. A gram doesn't really weigh that much in comparison to an ounce. I'm not going to use this one. You can. It'll still work. I'm going to use this one instead. So we go ahead and write down that conversion. Times, for every 28.3495 grams, we have 1 ounce. And we can figure that number out. Grams cancel out. 660 times 1 makes 660, so we'll end up having to divide 660 divided by 28.3495 grams. And that gives us 23.28083387 ounces. It's a long number. Now what I do is I keep that number stored on my calculator. I don't type it in. I don't type in 23.28083387. There's more numbers after the 7. There's an infinite amount of numbers that the calculator stores. So keep the number that's on your calculator currently, because we want to take that number, 33877 ounces, and we want to divide it by however many servings we have, because we want ounces per serving. So we're going to say divided by 12 servings, because there's 12 servings in the entire box. Now you can see we have ounces divided by servings. Divide that big number by 12, and you get 1.9400694898 ounces per 1 serving. Now the question wants us to round it to 2 decimal places. So this would round to 1.94 ounces. Now since this number is 1, and usually it is whenever we're finding these rates, we usually just write the per serving on the outside like that. So it's 1.94 ounces per 1 serving. So you'll see that little rate off to the side. And you'll see that in grocery stores when they say price per ounce, right? Whenever you're trying to figure out the prices to get more bang for your buck, they'll write it like that. This would be your answer. So that one involved a couple more steps. And this example right here, ounces per serving, that's what we call a rate. So the difference between a unit of measurement and a rate is a unit of measurement is just one by itself, but a rate is 2 separate units of measurement by themselves. So examples of rates would be maybe miles per gallon, like you're getting gas. You can have dollars per hour. How much do you make per hour wherever you work? You can have dollars per ounce, like I just mentioned earlier. Here you can have ounces per serving. A lot of different types of rates that you can find out. Again, speed, you can talk about miles per hour. Miles per hour, that's speed. So that would be another example of a rate. So rates, you can always calculate your own different one for each one. All right, so let's go ahead and move into something a bit more difficult. Some of the other problems between these involve more of the rate or the unit conversions. I want y'all to go ahead and work on those. I'll go ahead and help y'all out with number 39, show you how that works. It says Kayla bought a 12-ounce package of strawberries for $1.82. So a 12-ounce package of strawberries. Strawberries. And that's for $1.82. What was the price per pound for the strawberries? So that's what it wants. It wants price per pound. That's our goal. What is the price per pound? So we want to look at what we have. What we can do is, since we have 2 units of measurement already, and we could have done this on a serial problem as well, we can set up our rate immediately. Notice this is a price over a weight. So price over weight is what we want. So let's set up our current numbers like that, even if they're not the exact numbers. Price, $1.82 per weight, 12 ounces. So we have a dollar amount over a weight amount. That's what we want. So we have the rate correct. We just need to convert. We need to get ounces to pounds somehow. So we will need that conversion. We need to change ounces to pounds. So again, for every 1 pound, there's 16 ounces. Now when we multiply this one, we're not dealing anything with this dollar sign. The dollar sign is not going to change when we introduce this unit of measurement. We want to get rid of ounces. Ounces is on the bottom in this instance. So to get rid of ounces, we need to put ounces up on top. The pounds would then go on the bottom. Because ounces will disappear because they're dividing, you'll be left with pounds on the bottom. So put 16 ounces and 1 pound on the bottom, and you can go ahead and multiply across. $1.82 times 16 gives us 29.12 over 12 times 1 is 12. Divide that final number, 29.12 divided by 12. That gives us 2.42666666. It keeps going. It's a forever repeat, but it wants us in price. So we need to round to the nearest penny. That would be $2.43 per pound. That'd be your answer. Notice we don't put the 1 pound. We assume per pound means 1 at a time. So there we can set up the rate immediately and then try to get our ratios right. Our goal was to get dollars per pound, and that's what we ended up getting right here. So we ended up getting dollars over pounds. And after you get that, you just go ahead and multiply everything across. Dollars up on top, pounds is on bottom. And you want to remember that for future things when we work with recipe costs and everything else after that. Okay, let's look at this other one. This one trips up some people up on the quizzes and tests. I always have it on there. And it's because this is introducing a new concept when we're talking about conversions. Number 45 says 1 cup of butter weighs 8 ounces. What is the weight? What is the weight in grams? They bolded. Of 2 tablespoons of butter. All right. So this is where it throws people off. Here we see 1 cup. When we see cup, we immediately think a volume measurement. But in this case, it's not saying that. It says 1 cup weighs 8 ounces. So certain things you want to weigh by weight, some certain things you want to weigh by volume. Like if you take a cup of sugar You might not want to, you can use it for volume measurement, but weight measurement is usually better. Like if you're making a simple syrup, for a bar or something. Some people make their simple syrup recipe based off of a volume, some make it based off of a weight volume. Let's talk about baking. Like 1 cup of flour might weigh it'll weigh different than a cup of sifted flour. So everything will weigh different. A cup of butter would maybe weigh different than a cup of sugar, or a cup of water might weigh different than, say, a cup of not saying you'd use as much, but veggie oil because it's denser. So things weigh different than different things. A cup of potatoes is going to be heavier than like a cup of, I'd say, like parsley or cilantro or something light. So the cup is just the volume measurement, but it can be weighed at a weight measurement. So here, let's write that down. This says 1 cup is equal to 8 ounces. This is what we call a volume to weight conversion. That's a volume to weight conversion. Everything else that we've been working for is like volume to volume or weight to weight. Here we have a volume to weight conversion. It says, what is the weight in grams of 2 tablespoons of butter? So this is our goal that we want. We want it in grams as our answer. What we always do with all of these problems is start off with what's given to us first. What number is given to us? The number that's given to us is right here, 2 tablespoons. So we're going to start out with 2 tablespoons. Remember, this right here is just a conversion. It's not necessarily a number. It's a conversion. So currently we have 2 tablespoons. That's a volume measurement. We need to get to a weight. Grams is a weight measurement. But before we can get to grams, we need to get the tablespoons to a cup measurement, then cups to ounces. So first, you got to plan your attack for this. Let's change tablespoons to cups. So I'm going to put tablespoons on bottom, cups on top. We learned earlier that 1 cup has 16 tablespoons. It has 48 teaspoons, but 16 tablespoons. So write that down. This is 16 tablespoons for 1 cup. What we just did was a volume to volume conversion right here. But what we need to do now is, since we have the cups right here and cups, I can change that cups to 8 ounces, a weight measurement. So what I'm going to do is put 1 cup on the bottom, 8 ounces up on top. That then gives us a volume to weight change. And let me, I'm going to write these down a little bit. Oops. I'm going to write these down a little different in the way that I portray them. I just want to write the conversions a little different, or these. So this multiplication process right here is a volume to volume conversion. Here we're doing a volume to weight conversion. Now, ounces isn't the correct weight we want. We want grams. So now we need to change ounces to grams. We can go back to our conversion chart, and for every 1 ounce, and you can write that down in your little conversion list if you like, 1 ounce is equal to 28.3495 grams. 28.3495 grams. And then we can finally look at everything else afterwards. This was a weight to weight conversion. Boy, I just cannot draw on this thing. A weight to weight conversion. So you can see our volume to weight conversion happened with this guy right in the middle. We needed to do a volume to volume conversion to get to this conversion. And then once we were there to the weight conversion, we needed to change it to the correct weight. Now look at all your units of measurements. Let's look at all of them. Tablespoons cancels out. Cups cancels out. And then ounces cancels out. you're left with grams, and that was our end result that we wanted. Multiply everything on top. So 2 times 1 times 8 times 28.3495. Multiply all those top numbers, you get 453.592 divided by the bottom number 16. Divide that by 16, you end up getting 28.3495 grams. Now, I happen to come out to this because of the way the numbers worked. But that's your answer for that problem. Now, it asks us to round it to a whole number. So we have to say about equals, the nearest whole number is 28 grams. So be sure to look out for what unit of measurement to round it to, because I've had some people say, I didn't get the right answer. Well, I'm like, well, did you round to the right answer? And then once they round it to the correct answer, they usually get it. So look for what it wants on the problems, especially when it comes to the quiz. Pay attention to what it wants. All right. Let's go ahead and I'll do one more for you guys. This is going to be number 46, and it's similar to the one we just did. It says 1 cup of grated fresh Parmesan cheese weighs 3 ounces. So I'm going to go ahead and write down that conversion. 1 cup is equal to 3 ounces. And we're talking about Parmesan cheese. I just can't spell Parmesan cheese. It says, what is the weight in pounds? So weight in pounds of 3.75 cups of cheese. It says grated fresh Parmesan cheese. So we need to make sure it's the same type, like it's grated. If it was just a block of cheese versus grated, they're not going to weigh the same thing, because grated you might lose some, you lose some volume, in fact. So you got to make sure it's the same thing. So I'll go ahead and say grated right here, grated, and we'll say grated right here. They got to be the same type. They got to be prepped the same in order to make a fair measurement. So what is the weight of 3.75 cups? Start with your 3.75 cups. We need to get to pounds. Pounds is our result that we want. Cups is a current volume measurement. So we can actually go straight into our volume to weight conversion because we already have it in cups. So this could be 1 cup to 3 ounces. That would be your volume to weight conversion right there. Then we just need to change ounces to pounds. There's 16 ounces per 1 pound. That would be your weight to weight conversion. And you can double check. Cups cancel out, ounces cancel out. You're left with pounds. So we did the volume to weight conversion right away because we didn't need to convert something before. We had the measurement ready to go. Multiply all the numbers up on top. 3.75 times 3 gives us 11.25. Bottom numbers, 1 times 16 makes 16. Divide that out. That gives us 0.703125. And it wants us to round to the nearest hundredths place. So that'd be 0.70 pounds of grated cheese. And there's your answer. So this section is really important in terms of conversions because you use conversions throughout this section for 4, 5, 6, 7, 8. You're going to use conversions a lot. It's going to help you when it comes to some of the scaling stuff that we're going to be doing, and especially ingredient costs and your recipe cost forms. You're going to need to know how to do all of this stuff. So I would say this is probably one of the more rough sections because getting down conversions might be difficult. But this bridge method as it's called. This is called the bridge method, where you have a bunch of different ratios multiplying with each other to change the conversion. It's going to help you. It's a great way to just map it out. You don't want to do anything mentally. Always map it out, and then you can see how it works, because that's how you're going to do it on like a spreadsheet or something. If you make everything computerized, you want it to be mapped out to where it calculates it for you right away. And that's the best way to do it. Have a computer do the work for you if you know how to map it out correctly. All right, so go ahead and look over this lecture number 4. Homework, go ahead and do it. Then you can move on to lecture and homework number 5, which covers ratio, rates, and proportions. And those 2 topics will cover quiz 2.